recording. There we go. Kind of stuck. Remember we talked, what's the difference between a population and a sample? What's a population? Everyone within that group, whatever group it is. A sample is a portion of the population. It's a smaller. Cassidy, I got you. You're a little late, but I got you. Okay. So basically, think about this: is it feasible to get everybody of a population? If the answer is no, then you're for these questions, you're going to say a sample would be better, and then tell me what. Okay, all right, so whether a census is practical or not, population of interest is who you're looking at, okay? All right. Okay. People need more time? Okay. All right, who are we missing today? Missing Kaylee. Nicole. So that should give me 13 in here. 1, 2, 3. All right, let's go over this. So for each question, describe the population of interest. Okay. And so that basically population of interest, remember, is who are we interested in finding out about? Who or what? And then state whether a census is practical or whether it makes more sense to take a sample. What's the average time it takes U.S. employees to commute to work? What's the population of interest? U.S. employees. Okay. Is it practical to take a census? Kaylee, you're shaking your head no. Why? It's too many people, so it's better to take a sample. So take a sample. And it's too hard. It would be too hard to try and talk to every U.S. employee. All right. What's the average bedtime of students in this class? What's the population of interest? Students in this class. Don't just say students in general, it's students in this class. Okay. Okay. Census or sample? Census, because it's a small group, right? There's 13 of you. It'd be really quick and easy to go around and find out what the average bedtime is, right? Number 3, how much vitamin A is in the average carrots? What's the population? Carrots. All carrots. Would be just carrots. Census or sample? I think I heard both. Say it again. Census or sample? So census means you'd have to find all the carrots and then find out how much vitamin A in them. That'd be kind of hard, wouldn't it? So sample. Okay. Now, we talked about how to do samples yesterday. Types of samples. Just do a quick review. Now, this wasn't the only ways of getting a sample. It was just more common ones. And I talked about 3 of them. Who remembers one of them that we talked about? Did anybody watch the video? It was really short, right? It was only like about 8 minutes. Oh. So there are 3 types that we're going to be dealing with. First one is called a convenience sample. I'll go back here and we'll just kind of quick recap. All of this is already online. Okay. A convenience sample is easy and convenient. Hence the reason it's called a convenience sample. It would be like, let's say who lives near Johnson Springview Park? Anybody? Nobody? Well, let's say you did. And it's easy to walk over there, right? And just talk to people. That's convenient. But is that going to be a good representation? No. What if you have to go to the football game and you're like, oh, I have to do a survey for math. Okay, well, I'm going to be at the game anyway, so I'm going to talk to the people at the game. Would that be a good? It's convenient, right? Makes it easy. But because it is convenient, does not necessarily mean you're going to get a good representative sample. You may, but you may not. Okay. And you want a good representative sample. If you wanted to find the opinions of the students at Whitney High School, would you only talk to your friends? No. That would be a convenient sample, talking to your friends. That's not going to help you get a good representative sample because you want to be able to find out about everybody. Now, because of that, all right, then we have what's called a cluster sample. Homogeneous groups where everyone in that group is surveyed. So an example would be, let's say we want to, again, we'll talk about this students at Whitney High School. And admin wants to find, or leadership wants to find out about homecoming or something like that. and they randomly pick classrooms. And they go in that classroom and they talk to everybody in that class. That would be a cluster sample. Okay, so they would go, let's say they pick 10 classrooms to go talk to during third period. They pick Mr. Bannister's. They pick Miss Keene, Mr. Jimenez, Mr. Hunter, and they go and talk to every student in those classrooms. Now, is that going to give you a better sample of what people would want? It will, but will still maybe some groups be left out, because a good representative sample is you want to try and get from as many groups as you can. Okay, that's like if I want to find out about a question, something, do I want to just talk to the freshmen? No, I want to talk to each group. Now, do I want to talk to equal numbers of freshmen, sophomores, juniors, and seniors? Okay, is that going to give me a representative sample? So there's equal numbers of students on campus? Are the amount of freshmen equal to the amount of seniors? Oh, come on, you guys have gone to rallies before. Is the amount of freshmen equal to the number of seniors? Not even close. But it would still allow for each group to be represented. Sometimes we want to do it proportionally and say, okay, well, if there's twice as many freshmen than seniors, then we want to talk to twice as many freshmen. Okay, and that's where the next one comes in. But a cluster sample is you're talking to everybody within a certain group. It's the way the group is picked. Okay. Random sample is the best. It's where those surveyed are chosen by some form of a random generator. So it could be from the roll of a die, it could be from a flip of a coin, it could be where simple things so most on the computer you have random number generators and you can say, pick a number. And then, all right, so let's say it picks 10. If we put all the students in alphabetical order by their last name, and we picked every 10th student on that list to survey, we would probably get a pretty diverse group, wouldn't we? We wouldn't all necessarily get somebody from the same groups. There might be, but you'd get a better mix. So randomness is always needed. And that's kind of what we talked about a lot yesterday. And I think you saw that in your worksheet you had to do. It talked about random a little bit, whether this was a random sample or not. The other thing we talked about was the difference between a parameter and a statistic. If using a population in a census, we talked about censuses are expensive and difficult. With a population, it's a parameter. So whatever new information you get from that population, those are called parameters. Notice they both start with P's. Makes it easy. This is talking about like means and averages, stuff like that. Any data we get is a parameter when it's a population. If it's a sample, it needs to be a representative sample of that population. That's key. And whatever information we get from that is a statistic. So if it's a sample, it's a statistic that we use. If it's a population, then it's a parameter. P and P, S and S. Keep it, all right? So when you're asked, determine is this is a statistic or a parameter, read the question. Is it talking about a whole population? Then it's a parameter. If it's talking about a sample, then it's a statistic. That's basically it. Questions? Okay, so that worksheet that was yesterday, if you have, there'll be some time at the end so that you guys can ask questions of me, okay? All right, sir, you're still writing. So we're gonna go on to the types of sampling bias. Now we've talked about question bias, now this is sampling. And then we're going to talk about the difference between an observational study and an experiment. And then we'll be pretty much done with talking about the basics of stats. And that's the halfway unit part of this unit. We're at the halfway point. Okay? Anybody need to still write down? All right. So talk about sampling bias. Now, there's lots of different kinds of sampling bias. Bias just means something that's influencing. It's an influence. Like when we talked about questioning bias, it was bias that affected the responses and the influence the responders. All right, so sampling bias. First one we can talk about is undercoverage. This is a type of bias where one or more groups are underrepresented in the sample. All right. Now, even with doing all the right stuff, ooh, that's really bad spelling. Even with doing everything right, we can still have an undercoverage bias. And that just means, let's say in our group of 50 people we pick from the school, it just so happened that 15 of them are seniors. And there's only like 3 freshmen. Well, then the freshmen are undercovered, meaning they're underrepresented in our overall sample. Is that a bad thing? No, it's just it's something that happens, and we just need to note it when we do if we were doing a survey or an experiment or something. We just need to note that there was a possibility of undercoverage bias due to the fact that this group was not represented as much as this group. That's all. Okay. So then there is non-response bias. So this one happened. So what do you think this means? What do you think non-response bias means? And she didn't respond, right? Non-response. How many of you have ever gotten a survey in the mail or in your email? All right. Do you just throw it away? Or do you do it? What? You do it? You throw it away. Okay. And how many of you don't answer the phone call? Oh, it's just a telemarketer, right? Sometimes it's a survey. You just choose not to respond. So that is a non-response bias because they're getting the responses from certain people, and then only if those people are willing to talk, that's what's going to happen. I think I told you guys about the survey from the University of Michigan I did. I just happened to answer the phone that one time. And that's the thing. If I hadn't answered it, it would have been, they would have counted that as like a non-response because they look and said, well, we made this many phone calls, but we only got this many people to respond. And so that's just what a non-response bias means. It means you choose not to respond. You choose not to answer the question. And that happened a lot in 2016. Prior to 2016, the polls for the presidential election were generally dead on. And a lot was written about what happened in 2016 because the polls were not dead on that time. And so when they went back to talk to the people said, I didn't tell you the truth because I didn't want to feel that I was going to be persecuted. I chose not to give you a good response. That is a key thing about this, is if they choose not to respond or choose to give you false responses, then your survey, your poll is worthless. All right, because you are sitting there hoping that the people are telling you the truth. But you're not in their head to know whether they are or not. So that's the thing about a non-response bias. Sometimes people will just choose. How many times have you're somebody standing at the door at the grocery store, hey, can I ask you some questions? No, you keep walking. All right, happens quite a bit. Non-response bias, that's what that is. Now that brings me to internet surveys. How many of you seen those surveys on the internet? Like this survey, we took this survey from the, like we sent, these are from the respondents of this website. Here's what we're saying is true. Internet surveys are crap. Okay? They're not reliable in any way, shape, or form, because who's going to be underrepresented on an internet survey? Anybody? Who would be represented? Underrepresented. Somebody who doesn't have a reliable computer or goes on the internet, right? Do any of you have like grandparents who don't like to get on the computer? Yeah. Or they would have had to see that particular question. And also the people who respond to those, and I get so irritated with, because my husband will do them. And he believes them. And I'm like, don't do that. They're not, because only the people who were, or you take those surveys, like, are you that, which Disney character are you? Right? Those kinds of ones. Don't believe. Internet surveys are crap. Don't believe their results, because of the fact only certain, many people don't respond. So there's a huge non-response bias in that one. The last one is a response bias, and that is generally based on a biased question. Okay, so because the questions are biased, the responses are going to be biased. All right. So when we think about bias, we need to kind of think of a couple of things. One, in any survey you get, you need to think about, are these questions biased? Just for any survey you read about in the news or in an article or whatever, every poll, you got to think about one, if they don't give you the question they asked, that's kind of a kicker right there. They should be able to honestly tell you what question they asked. If they don't give that question, there's probably a little bit of a bias there. But read that question and say, was this a question a fair question? Or is it biased? Is it going to influence people being surveyed? All right. Then if you are doing your own survey, you try to reduce the bias as much as you can. Can you completely can you get rid of it completely? There's no guarantee you can do that, but you try to reduce it by making sure your questions are fair You're getting a good representative sample. That's the two key things. A fair question and a good representative sample. We don't, in stats, we go into much more detail about how big your sample and everything else has to be, but we're not going to do that here. Those are the two main things you guys need to think about. To reduce your bias, you need to have a fair survey question and a good representative sample. A good representative sample means you did a random sample. Because in that, you want to think about anybody who may have been excluded with that survey. Okay? Questions so far? So let's move away from surveys. Let's talk about a study. Eric's. Okay? So, right now, I know you've heard in the news that they're testing vaccines, right? And to do that, there's two ways to do it. They're doing experiments is what they're doing. And it's not like an experiment like you think about, think that they're, like they're working with, when I hear experiment, I think like science class. Yeah, it's not that kind of experiment. What they're doing, there's two things. There's an observational study and then there's an experiment. And an observational study is just that. It's you observing. You're watching. Watching your sample. And noting whatever you want, noting. Okay. So think of it, it's that. You're going, so let's say we want to find out how many people eat, do they still have the Bosco sticks in the cafeteria, right? They still sell those? Or chicken nuggets? Do they still do the chicken nuggets or the teriyaki chicken bowls? Oh no, don't know. Okay, so let's say the Bosco sticks. Well, I want to know how many students get Bosco sticks every day. So what I do is I go down to the lunch and I just walk around and I keep track of how many people I see with Bosco sticks. Okay, that's an observational study. That's you looking and seeing what's going on. Sitting at a park to see how many children come. Do parents bring their children to the park on a daily basis? You go to the park and you count how many children you got there. Okay, that's an observational study. How accurate is that? What do you think? Would that be would you be able to accurately say how many students eat Bosco sticks in the cafeteria? You guys are laughing at me. Or how many parents bring their children to a park? No, observational studies, you can't make a reasoning from it. That's why there's no cause and effect with an observational study. So you can't make a conclusion. To apply to a population. All right. To be able to apply a conclusion, you need to do an experiment. Okay. Now, I'm not going to get into great details about what for an experiment, but basically, you have to apply some form of a treatment. And treatment's just a general term. So like if I wanted to say that exercising 3 times a week will improve your health, the treatment would be exercising. So we want our sample to exercise 3 times a week. That would be the treatment. So exercising. I want to show that sunscreen will help reduce the risk of cancer. So the treatment would be our sample would be asked to apply sunscreen. Okay. Your sample is asked to do something, basically, or they're given something. So like right now, when we're talking about the vaccines, when they go to start doing testing it on people, they'll ask people to take it, and then they will monitor how it affects them. That's the basics of it. So the treatment would be applying the vaccine. Because of the fact we're applying a treatment, we can make a cause and effect. We can make a conclusion based upon our findings. All right. So, give me an idea. So, my brother works for a pharmaceutical company, and he's talked to me about when they do their experiment, they call them experimental studies, rather than just saying experiment. That for each drug, it costs them between $500 and $600 million in studies, and they're running their studies before they can come to market, because of all they have benchmarks and things that they have to meet, and many times they have to start over because something changes, something happens in their study, and they realize, okay, we need to go back and redo this and start over. But once they get through all that and they realize, yeah, okay, now we're getting the findings and the things that we want, now we can say that it's going to do this. Okay? But that's an experiment. Now, the thing about an experiment is it can have what's called a lurking variable. And a lurking variable is just something outside of the control. Something outside the control of the experimenters that can influence the results. Okay. It's something you can't plan for. Let's put it that way. You can't plan for it. So let's say like we want to test window treatments on a house to see if it reduces the temperature and the amount of UV rays that come into the house. Okay. And we put them on the south side of the house, right? And we're going to run it for 2 weeks. Well, it rains those 2 weeks. Would that affect your findings? Yeah. So lurking variable would be the fact that it rained. And maybe you need to redo the study, or do the experiment for a little bit longer, or go back and try it again. It's just something that's outside of the control of the experimenters. Okay. Sometimes you can know what it is, sometimes you don't. It's just a lurking variable is just something that's outside the control of the experimenters that can influence the results. That's all you need to know about it. Okay. Any questions? So if I asked you in your own words to explain what an observational study is and an experiment, you could? Observational study, you're watching people or you're watching something. In an experiment, you're applying some form of a treatment. Okay. All right. So how much time? We got what, about 40 minutes? Where's my schedule? Okay, so I am going to stop. This is it for the lesson for at home. And now I'm going to give out your quizzes, your ESAs, your last ones. All right.